Okay, so let's take a look at this related rates problem. I'm going to work through this using the 6 steps from our pink sheet. It says a cylindrical tank is filled with water. This tank stands upright and has a radius of 20 centimeters. It says, is this number changing with time? How fast does the height of the water in the tank drop when the water is being drained at 25 cubic centimeters per second? Hint, look at the units on the 25 to see what this number is in symbols, and it gives you an answer. Okay, I think step 1 was to draw the stinking picture. So let's draw the picture first. Cylindrical tank. So here's my tank. I'm going to take that back. Okay. Let's go again here. Here's my tank. Water's being drained out of the tank. So here's the water in the tank. Tank stands upright and has a radius of 20 centimeters. Remember when I put labels on my picture, I put numbers on things that are not changing and letters on things that are changing. Okay, so the tank stands upright and it has a radius of 20 centimeters. And what we're talking about is the height of the water in the tank. So it's not like the cylinder, the tank itself is expanding and shrinking. It's the water that's going up and down in the tank. So that means that the radius of the tank is constant. It's not changing. So I'm going to put a number on that. So the radius of the tank is 20. But this height in here, the height of the water is changing. So I'm going to put a letter with that. I'm going to put an H with that. Okay. All right. So I've got my picture. I've put numbers on things that are not changing and letters on things that are changing. That is like H is a function of T. Alrighty. So step 2 is to write down what you are given in the problem. Okay, so let's see, what am I given in the problem? It tells me that the tank is being drained at the rate of 25 cubic centimeters per second. And it says to look at the units on the 25 to see what this number is in symbols. Well, it says cubic centimeters, so that's a volume per second. So I know then that what they're trying to tell me there is that the volume is changing with respect to the time, dV dt, at the rate of 25. And since the volume is decreasing as the water is being drained out, I'm going to put a negative with that. Okay, so again, I found that dV dt by looking at the units. It's cubic centimeters per second. That's time. So dV dt. Okay, and they also tell me that R is 20, and that's not changing. And what I'm trying to find, what is it that I'm looking for here? How fast does the height of the water in the tank drop? So how fast does the height of the water in the tank drop? So that tells me I'm looking for a rate of change. How fast is something changing? And so I'm looking for dH dt. How fast is the height changing as water is being drained out of the tank? Okay, so I know what I'm looking for. I know what I'm given. The next step is to write some equation that relates these variables together. So my variables I have here are R and H and V, and everything is changing with time except the radius is fixed at 20. So I need the volume of a cylinder. So the volume of a cylinder is pi r squared h. If you didn't know that, look it up, Google it, whatever you need to do. The volume is pi r squared h. But they tell me that r is 20, so I'm going to put that into my equation. So that's pi times 20 squared times h, or v equals 400 pi h. Okay, so then I have an equation that relates h and v together. I'm looking for dH dt, and I'm told what dV dt is. Okay, great. My next step, I believe, is to sprinkle some t's in here. So that is volume is changing with time, so I'm going to say v of t equals 400. It's constant, pi is a constant, but h is changing with time. Okay, Now I'm ready to take the derivative. So the derivative dv dt is dv dt equals 400 pi. Okay. I don't need a product rule because 400 pi is a constant, so no product rule is necessary. And then I'm going to take the derivative of h with respect to t. The symbol for that is just dh dt. Okay, just like the symbol for the derivative of v was dv dt, the derivative of h is dh dt. Okay. I didn't have to use a power rule. There wasn't any, like an inside was h of t and outside was squared. It's just derivative h is dh dt. Okay, now I'm going to put in what I know and solve for what I don't know. Okay, so I'm going to scoot up here. So I'm going to say dv dt is negative 25 equals 400 times pi times dh dt. Solving for dh dt, I'm going to divide both sides by 400 pi. So I get dh dt is equal to negative 25 over 400 pi, which simplifies to negative 1 over 16 pi centimeters per second. Okay, and that is the answer that's given. Okay, I think that does it. Key things I think here, draw the picture. Again, put numbers on things that aren't changing, letters on things that are. Write down what you're given in the problem. It helps to look at the units. Cubic centimeters per second, that tells me that's a volume with respect to time. I'm looking for how fast the height is changing. That's a rate of time, so I'm looking for dh dt. Okay, I think that's done.